Hello students, Namaste. Welcome to Ignite 7 Chemistry classes. In today's session, we are going to solve few important questions based on mole. Let us start our session with our first question. Calculate volume of A 6 grams of hydrogen, B carbon dioxide produced by 125 grams of calcium carbonate of 80% purity Question number 3, C 3.01 into 10 power 23 particles of O2. We have to solve these three questions. For that, let me recall a mole is equal to 6.02 into 10 power 23 particles. Mole equal to 22.4 liters at STP. Mole is equals to gram molecular weight. Now, first 6 grams of H2 we have to find the volume. Anything first we have to convert into mole. 6 grams of H2 is equal to how many moles? N is equal to given weight by molecular weight, that is 6 upon 2 grams, that is 3 moles. And we know 1 mole is equal to 22.4 liters, then 3 moles x liters, then x is equal to 22.4 into 3 liters, that is 276 liters. 67.2 liters is occupied by 6 grams of hydrogen gas. Question number 2 in this. CO2 produced by 125 grams of calcium carbonate of 80% purity. First, calcium carbonate 100 grams is equal to 1 mole, but here it is given 125 grams, but the percentage of purity is 80%. Now 125 into 80%, 80 upon 100 is equal to 4,757. So it is 500 upon 5 is equal to 100 grams. So 80% of 125 grams is nothing but 100 grams. 100 grams of CaCO3 is 1 mole. If you take 1 mole CaCO3 on heating, we'll get 1 mole calcium oxide plus 1 mole carbon dioxide. 1 mole carbon dioxide is nothing but 22.4 liters. So 125 grams of calcium carbonate contain only 100 grams in it because it is 80% pure. From that we get 1 mole CO2 which is equal to 22.4 liters. That's the second question. And third question, 3.01 into 10 power 23 particles of O2. So 6.023 into 10 power 23 is nothing but 1 mole, is nothing but 22.4 liters. Then 3.01 into 10 power 23 is half a mole, is nothing but 11.2 liters. Hope it is clear. So here we have converted weight into volume. Here we have converted weight into volume, but there is a small conversion takes place at the percentage of calculation, and here particles convert into volume. Now let us continue with few more interesting questions like this. Calculate number of molecules present in Calculate, question number 2, calculate number of molecules present in 34.20 grams of sucrose, and B, number of molecules in 1 liter water if density is equal to 1 gram per ml. C, calculate diameter of one water molecule. 3 questions. In that, let's start with the first one. Calculate number of molecules present in 34.20 sucrose. Sucrose formula C12H22O11. Now the molecular mass of sucrose is 342 grams. 342 grams is equal to 1 mole. Then 34.2 grams is equal to x mole. The number of moles is equal to x is equal to 34.2 upon 342. So 1 by 10, 0.1 mole. So 0.1 mole is nothing but 0.1 into 6.02 into 10 power 23 is equal to 6.02 into 10 power 22 molecules present. Here we have converted weight into molecules. Second question, number of molecules in 1 liter water. We have 1 liter water, but density is equal to 1 gram per ml, then 1 kg per 1 liter. Then given volume is 1 liter, then mass of 1 liter water is equal to m d by v. Here density is 1 kg per 1 liter upon 1 liter. Then we get 1 kg, that is equal to 1000 grams. So water weight we got 1000 grams. The number of moles is equal to 1000 upon 18, that is 55.5 moles. So we got 55.5 moles. Then what are the number of particles in it? That is 55.5 into 6.02 into 10 power 23. Then we can write it as 0.555 into 6.02 into 10 power 25. This is 6 5s are 3, nothing but 3.3 into 10 power 25 molecules. So first question done, second question done, and the third question, diameter of one water molecule. Here 18 grams is nothing but 1 mole, is nothing but 18 ml. Now 1 mole 6.02 into 10 power 23 particles is equal to 18 ml, volume 18 ml. Then 1 particle volume is equal to 18 upon 6.02 into 10 power 23. This can be written as almost 3 times. 2.98 into 10 power minus 23 ml. This is a volume of 1 water drop volume. So it's a sphere. So it is 4/3 pi r cube. 4/3 pi r cube. Now r cube is equal to 2.98 into 3 upon 4 into 3.14 into 10 power minus 23 ml. Here This is approximately 3. This is 3. You can take it as almost 9 by 4 into 3.14 into 10 power minus 23. 4 3s are 12. So 4 1s are 4. So 4 4 is 16. You will get 9 upon 12.56 into 10 power minus 23. This will be equal to, so 12 6 are 12 6 are sorry 12 sevens are 84. So 12 sevens are, you will get almost 7 point something into 10 power minus 23, right? Now 7 into 10 power minus 23, sorry, 0.7 into, sorry, it is 0.7. 0.7 into 10 power minus 23 can be written as 7 into 10 power minus 24. This is r cube. Then r is equal to 7 whole power 1 by 3 into 10 power minus 24 whole power 1 by 3. Then it is 7 power 1 by 3 into 10 power minus 8. Then 7 power 1 by 3. To calculate power of 7 power 1 by 3, we will use logarithm. Log 7 power 1 by 3 is equal to 1/3 of log 7. So log 7 is 0.8. So 1/3 of 0.8. So it is 0.85, approximately 0.85. 1/3 of 0.85 is log 7 power 1 by 3. So this can be 3 2s are 6. Again 2.9 nearby will get 2.9. So nothing but 0.29. So log 7 power 1 by 3 is equal to 0.29. Log 7 power 1 by 3 is equal to 0.29. So if you apply anti-log both the sides, anti-log of log 7 power 1 by 3 is equal to anti-log of 0.29, we can write it as approximately 0.3, that is log 2. Log 2 is 0.3. So log anti-log cancel, anti-log log cancel. So 7 power 1 by 3 is equal to 2 approximately, or more accurately it will be 1.99. It is 1.99, no doubt in that, because log 2 is 0.3. Here it is approximately log 2. So it is not 0.3, it is approximately 0.3, so it is approximately 1.99. Now 7 power 1 by 3 is 1.99. Then we can take here 7 power 1 by 3 is 1.99 into 10 power minus 8 is a radius. Then diameter is equals to 2 times of the radius, that is 2 into 1.99 into 10 power minus 8 centimeters. This is diameter of one water molecule. Hope it is clear. So now we have calculated molecules present in 34.20 grams, number of molecules in 1 liter water, diameter of one water molecule. So for this calculation what we did, 6.023 into 10 power 23, 1 mole is equal to 18 ml. Then 1 molecule is divided by 18 by 6.02 into 10 power 23 ml. That is equal to that is equal to 2.98 into 10 power minus 23. Now that is 4/3 pi r cube. It is volume of sphere. Then r cube is equal to this. From this we have calculated r value. 2 into r we got diameter. So for that log and anti-log calculation, if you want, you can check it out my video in my playlist. Now let us continue with few more questions. Next question, calculate number of CO2 particles in 350 centimeter cube volume at 273 Kelvin temperature and 2 atm pressure. So given data, temperature 273 Kelvin and pressure 2 atm, volume 350 centimeter cube. Now if you take temperature 273, pressure 1 atm means at STP condition, and volume will be how much? I am converting the given condition into STP condition to find the volume. So take this as V2, V1, P1, P2, T1, T2. Now V2, P1 V1 by T1 is equal to P2 V2 upon T2. Then T2 into P1 V1 by T1 into P2 is equal to V2. Here T2, T1 same, cancel. P1 2 atm into V1 350 upon P2 1 atm. So atm cancel, you will get 700 centimeter cube because it is 350 centimeter cube. So V2 we got 700 centimeter cube. Now 1 mole CO2 at STP will occupy 22.4 liters. That is nothing but 22,400 ml. Now we have only 700 ml with us. And what are the number of moles? X. Then X is equal to 1 mole into 700 ml upon 22,400 ml. ml cancel, 100 cancel. Then it is 7 into 1 mole upon 22.4, sorry, 224. So 1 mole is nothing but 7 into 6.02 into 10 power 23 upon 22.4 into 10. So 10, 10 cancel. Then you will get 7 into 6 into 10 power 22 upon 22.4. Nearly 7 3s are 21. So 14 is there. 7 2s are 3.2. So that is 6 by 3.2. 3 2s are 6, but it is 1.8 or 1.9 into 10 power 22 molecules will get. Hope it is clear. So with this we have completed few numericals based on mole. Now let us learn about limiting reagent. What is limiting reagent? What is limiting reagent? Limiting reagent. To understand this, I am going to give you a very simple example. In case in the early morning when you are having breakfast, you are eating one dosa with 1 spoon chutney. If you have 10 dosas, definitely you need 10 spoon chutney so that you can finish the breakfast. But unfortunately, if you have 10 dosas with you but you have only 8 spoons of chutney, then you can eat only 8 dosas. The remaining 2 dosas will be left over. Since you are not able to eat them because the amount of chutney which is present is less in quantity. Now, whichever the substance which is controlling the process, whichever the substance is not letting the reaction to complete, is known as limiting reagent. Here, this is limiting reagent. So, limiting reagent is a substance which is not going to let the reaction complete, and it will be present in lesser quantity when compared with standard quantity. Let us take a similar example in chemistry. We have N2 plus 3H2 gives rise to 2NH3. Here N2 weight 28 grams, 6 grams, then it will give 34 grams of ammonia, 2 into 17. Here, in case if you take 28 grams and you took only 4 grams, then who is limiting reagent? The one which is less in quantity as compared. Actually required only 6 grams, but we have only 4 grams. So hydrogen is a limiting reagent. In case if you take 2.8 grams of nitrogen and 1.2 grams of hydrogen, which is limiting reagent? In that case, limiting reagent is nitrogen. Don't see that this is more than this. No. So we have to compare limiting reagent. 28 grams require 6 grams. Then 2.8 grams require only 0.6 grams. 2.8 gram require only 0.6 grams. But we have 1.2 grams. Then which is more in quantity? Hydrogen is more in quantity. Nitrogen is less in quantity. So this is limiting reagent in this case. Now let us start calculations based on limiting reagent. Question number 1. Calculate amount of ammonia produced when 14 grams of nitrogen react with 14 grams of hydrogen. 14 grams of nitrogen react with 14 grams of hydrogen. Now let's see the reaction. First we have to find which is limiting reagent, and where the product is going to be decided by limiting reagent. The amount of product is going to be decided by limiting reagent. Now N2 plus 3H2 gives rise to 2NH3. So here standard conditions required, this is 28, this is 6 grams, then we'll get 34 grams. But in our question, it's given only 14 grams. Then it will consume only 3 grams. Then half only will be consumed. But it is given 14 grams. So what? It will react only with 3 grams. The remaining 11 grams will be left over. Because this is a limiting reagent, this sign. The limiting reagent is nitrogen. Now 14 grams with 3 grams will produce 17 grams, and out of 14 grams 3 grams of hydrogen is gone, then 11 grams of hydrogen will be left in the reaction. But amount of ammonia produced is only 17 grams. Now the amount of ammonia is decided by limiting reagent, that is nitrogen, not by hydrogen. It's clear? Now let us solve one more question on limiting reagent. Calculate amount of water produced when 32 grams of CH4 react with 8 grams of O2. 8 grams of O2. So the actual reaction will be CH4 plus O2 gives rise to CO2 plus 2H2O. Here this is 2O2. 16 grams, CH4 molecular weight 16 grams, reacting with 64 grams. 16 grams reacting with 64 grams to produce 2 moles of water. Then 2 into 18 grams, that is 36 grams. First let us see which is limiting reagent. 16 grams react with 64 grams. Here in the question it's given 32 grams, then it will actually react with 128 grams. But in the question it is given only 8 grams O2. 8 grams O2. Then this is the limiting reagent. 8 grams O2 is the limiting reagent. Now 64 grams, the amount of water, how to calculate? 64 grams if O2 there, then we'll get 36 grams. Then 8 grams if it is there, x grams, cross multiply. X into 64 is equal to 8 into 36. Sorry for the interruption. X into 64 is equal to 8 into 36. Then x is equal to 8 into 36 upon 64. 8 8s up. Now 36 upon 8 is 18 upon 4. 9 upon 2. 4.5 grams. The amount of water produced is 4.5 grams. Hope it is clear. So in today's session we have learned numericals based on weight to mole and weight to volume, as well as volume to number of particles, and limiting reagent numericals based on it.